Hi. In this video, we'll find Z transform for the sequence which is equal to cosine omega n u n. Well, to do that, first we have to write the expression for cosine. Cosine omega n can be expressed as the sum of the exponential function e to the power of j omega n plus e to the power of minus j omega n divided by 2. So now, to find Z transform for the cosine wave, just we have to start finding Z transform for e to the power of j omega n. Z transform of e to the power of j omega n, and don't forget we are going to multiply it by the unit step because it's here. The definition of the sum is equal to from n minus infinity to infinity, but since we have it start from multiplied by the unit step, it means it will start from 0. So you have here n is equal 0, and that's the function will be e to the power of j omega n multiplied by z to the power of minus n. And we know to have the geometric series, we have to have something here to the power of n. So e to the power of j omega and n left out, so e to the power of j omega, and z to the power of minus 1 and n is common for both. So you can approximate the sum of the geometric series from n, start from 0 up to infinity, equal to 1 over 1 minus whatever in the bracket here, a j omega z minus 1. And if you like to express this expression in z to the power of positive power instead of negative 1, very simple. All what is supposed to do, just multiply the top by z and the bottom by z. Z times 1 is equal z, z times 1 is equal z, and then z times z minus 1 will cancel, and just you'll have e j omega. So this is the expression for Z transform of e to the power j omega n. Well, we still have to find Z transform for e to the power of minus j omega n. You don't have to repeat these steps again. Just take this one and change the sign of the e to the power of j omega. So simply you can say Z transform of e to the power of minus j omega n un will be the same as we got before. The only difference will be putting negative sign here in front of j omega. So that's the final expression for Z transform of e to the power of minus j omega n. Now I want to find the cosine. The cosine, just you have to add them and divide it by 2, and that's what I'm going to do. Z transform of cosine omega n un will be equal to this expression plus this expression divided by 2. I will say half z over z minus e to the power of minus j omega plus z over z minus e to the power of minus j omega, and this one should be a positive. Now I need to simplify the expression. Obviously I got to find the common denominator, and the common denominator here will be z minus e j omega times z e minus j omega, and then you start to multiply this part by this part. Z times z is equal z square, z time minus e will be minus z e to the power minus j omega. I finish this side, then the other side, z times z will be equal to z square and minus e ag omega. So now I have this expression, and we'll try to simplify it more. It will be equal to 1/2. I'll multiply the one on the bottom here. Z times z is equal z square. Z times minus e will be minus z e to the power minus j omega minus e to the power z minus z e to the j omega. Multiply both, exponential being positive, e j omega, e minus j omega. And the one in the top here, you have z square and z square, you got 2z square minus z, take as a common factor. What's left? A g omega plus e minus j omega. All right. Observe this term. We have e to the power of something times e minus something will be e to the power 0, which is equal 1. So this term reduced to 1. Now I have 1/2 2z square minus z. And let's just look at this expression. E to the power of j omega plus e to the power of j omega, this is equal to 2 times cosine omega. All right. And the bottom here, you have z square. You got minus z and minus z, take it as a common factor. You have e to the power of j omega plus e to the power of minus j omega. And you have the 1 here. Again, this term, I will reduce it like we did in the top part. 2z square minus z. You have 2 here outside, cosine omega, divided by z square minus z. And this term is equal to cosine omega plus 1. Well, it's done. And if you want to reduce more, you can reduce more because you have z here in common. So you can say that, and you have half, you have 2 and 2. So if you take 2z as a common factor on the top, so you got z minus cosine omega divided by z square minus 2z cosine omega plus 1. So this cancel. So that's what you got. The final expression, z times z minus cosine omega divided by z square minus 2z cosine omega plus 1. And that would be the final expression for z transform of cosine omega t. I hope that was clear.